Okay, students, how are we going to draw the tailstock clamp? So the first thing to note is it is a metric drawing. It'll tell you here it's metric. The other thing to tell you, as a hint, is the size of them. If you notice, it says 127, 105. Anything that's that big would actually be in millimeters. So this will be metric. Other than that, it will tell you that's in metric. So whenever we have a metric drawing, I go in here to click new, and I always like to do that to bring up the templates, because on the templates it will tell me what units I can work with. Okay, so remember, English units are inches and metric units are millimeters. And right now we are working with part files. A little later in the semester we are going to work with assemblies, and eventually we are going to create drawings with dimensions and title blocks and all that stuff. That's a little later. An assembly is what we're going to be doing really soon. But for now, we're just going to work on the individual part files, which is why it's called a .ipt file, which is Inventor. And you can see right there, it's already in millimeters and creates. Okay. I'm going to go ahead and create this part file. It's in metric millimeters. I wait for Inventor to load the information for us. Okay, so what we're going to do is we're going to start with a 2D sketch. I will explain on a later recording on how to work with a 3D sketch, but for the most part, we're going to work with a 2D sketch, so we're going to start there. Which plane? Okay, technically it really doesn't matter. Once you get a little bit more experience with Inventor, you'll probably see which one is of more benefit. For this one, I'm just going to use the X and Y plane to start my first sketch. And the way I'm going to approach this is I'm going to start with a sketch of the shape of this shape right in here, which is the outer edge of the shape here. A line, another line, a couple of other lines to finish that one up and extrude it, okay? So that's the approach I'm going to take. So you can kind of see that, I guess it kind of aligns itself with the X and Y plane. Doesn't have to be, but I'm just going to do that here. I think it'll just make it a little bit easier. So that's the one I'm going to use for this sketch in particular. So X and Y. So there we go. Okay. Now, the sketch that I just kind of drew right now, you saw it, me draw it quickly. The sketch, I'm going to draw it as a sketch. It's not going to be exact. It's going to be a sketch, but you do want to be as close as possible. So I'm going to draw myself a line. And the first line along the bottom is about 105 millimeters. So I'm just going to start over here somewhere. Click over here, and I'm going to come across to about 105 millimeters. Again, not exact. So I'm going to zoom out a little bit, 105 millimeters. The other thing too, notice that where I'm sketching is close to the origin. I'm not sketching out here in La La Land somewhere. I'm actually pretty close to the origin. And that's kind of where you want to be. Not necessarily on the origin, but close to it. And I'll tell you why here in a little bit. So it's about 105 millimeters. And then it's going to come up, it looks about 9 millimeters or so. And then across. And then there's an arc in there. I kind of want to draw the arc at the same time, but I really can't do that from this command. I can, but it'll draw an arc that's tangent, and I kind of don't want to do that. So this is something I don't usually like to do in Inventor, is stop my sketch and draw little pieces of arc and everything. I usually don't like to do that. That's not a good thing. Sometimes you have to, but I am going to do that here. Usually you want to sketch the whole thing all in one command and close it up and finish up the whole sketch. In this case, I can't do that. So I'm going to have to hit escape, unfortunately. I'm going to draw myself an arc, a 3-point arc, and just an arc from here, 3 points somewhere around like this or so. Okay. And then continue with the line that I need. From here this way, I'm going to come across. Now here, there's another little trick that I can use. It's I'm going to draw myself an arc, but I do need that to be tangent to this line. So within the same line command, I'm just going to come back to this point, press and hold my mouse, and then drag out an arc from there. Okay, so I'm going to drag it out, and I do need it to be aligned with that other side. So you see that little dashed line that's coming across. I do want that to happen, so I'm going to release it at that point, then come across to here, draw it to there, and to there. Okay. So then pretty much a couple of things that are happening. You can kind of see that I have these little weird symbols. Those are called constraints, okay? I'm going to hit escape to get out of the line command, and my constraints disappear. But to show my constraints, I'm going to hit the F8 key. F9 will turn off the constraints. Again, I have to hit escape and get out of the line command to be able to use and see my constraints. A couple of constraints. One that I need to add is a tangent constraint. You can kind of see this arc is not tangent to this line. It's not smooth, kind of like this one. So this one constrained itself tangent. So before anything, what I'm going to do, I'm going to make add the tangent constraint. So I'm going to add it tangent from here to here. I need those to be tangent. And then usually what you want to do, you want to start with this one first, the coincident constraint. That is to lock the sketch onto the X and Y 00. So I'm going to use a coincident constraint. Usually the middle, it doesn't have to be, but I'm going to hover over to find the middle point. There it is. And then I'm going to apply the coincident constraint again from that middle point to the origin. Okay. And I'm starting to constrain the sketch. So then at this point, I have 8 dimensions that I need. Okay, so the 8 dimensions doesn't necessarily mean that it's 8 of these dimensions. Okay, it doesn't necessarily mean that. It's just that I need to apply either geometric constraints or dimensional constraints. Okay, but first things first, you want to start with geometric first. And geometrically, let's see if what we have here. Let me see. To find constraints, I'm going to hit a F9, turn them off, and then move these lines around. Okay. All right, so you notice that this one doesn't stay aligned with this one. So I want them to be aligned. So what I could probably do, I can apply an equal constraint to make this line equal in length to this one. But another one I can also apply is a horizontal constraint, where I can horizontally constrain this point to this point. So horizontally, it will be aligned, and that's to me that's a better one than the equal constraint. I think a little people overuse the equal constraint. You probably should use some of these other ones more so than the equal, even though we could have gotten the same thing with the equal constraint. Okay, so that one there, and then the other thing too is I need this one according to my yeah. I need this one to be equal in length to this one. So I think I do have to apply the equal constraint from this one to this one. So I make them equal in length. The other thing too, it's this sketch. It's not in the middle, so I need that to stay in the middle. So I'm going to apply a vertical constraint to vertically constrain the middle of this line to the origin. So that way it's vertically constrained, okay? Now, again, you notice that the sketch got a little weird, so I'm just going to sketch it, move it down here a little bit. So you notice it got a little out of shape, and that happens a lot whenever you sketch out here somewhere, and then you apply your coincident constraint, and then the sketch gets all weird shapes, and it just doesn't work too well. So that's why you always want to sketch close to the origin. All right. So I'm down to 5 dimensions. So I think at this point is where I can now start applying my actual dimensions. For example, let's count them. I'm going to predict that I'm going to need the 38s, the 9. So that's 1, 2, 3, 4 for the arcs. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But for some reason or other, I thought we would need that one too. 1, 2, 3, 4, 5, 6. So, interesting. I think it should be 6. Inventor says 5. Well, let's find out. Okay, dimension from the bottom to the top. That needs to be 38. Okay. And then this line here needs to be 9 millimeters in length. This line here needs to be 105. And then down to 2 dimensions. This guy from here to here, that needs to be 127. And 1 dimension needed. Ah, yes, very good. Because of my geometry, both of them have a radius of 29, but because of the fact that they're tangent and all these other dimensions, I only need to dimension one radius. That's why. And that's why it says 1 dimension. So there we go. Select this guy, and that has a radius of 29. Enter. Very good. Fully constrained. Okay. This actually looks a little bit different than the sketch. I envisioned it a little bit flatter, but hey, it is what it is. Excellent. Very good. Fully constrained, that's what you want, finished sketch. Okay. Now, one thing I'm going to do is I'm going to extrude it. Okay, we need to extrude it a full of 58 millimeters. But this is what I'm going to do that's a little bit different than what a lot of you guys are doing. I'm going to go the distance of the 58 millimeters. Okay. But what I'm going to do is I'm going to change the direction because you can change it from the default direction to the flip direction or symmetrical, which is basically 58 divided by 2. So it divides it by 2. You can also do asymmetrical, where you would put in the distance from one side to the other. That's called asymmetrical. Don't use that a whole lot, but I will use this one in this case. Okay. So I'm going to go symmetrical for a total of 58. So from the origin, it's going to go half and half for a total of 58 millimeters. Okay. There's a reason why I did that, because now what I'm going to do is I'm going to now do a sketch to cut out this little piece. Okay. The sketch I'm going to do is a sketch of this shape here. Okay. And this shape, I'm actually going to do it from the middle. I'm actually going to draw that shape in the middle and do a cut extrusion from the middle. Okay. So then to do that, the way I'm going to do that is I'm going to create a sketch, but I am not going to pick any of these faces. What I'm going to do is I'm going to pick the original origin X and Y plane. So to create my sketch, I'm going to expand this thing over here that says origin. And I have my X and my YZ, XZ, and XY plane. So my sketch, I'm not going to sketch it on any of these. I'm actually going to sketch it by expanding the origin, the X and Y plane, select. So that is where I'm going to sketch right in the middle. Okay. Of course, I can't really see in there. So a new F key I'm going to show you is called Slice Graphics F7. F7, what it does, it slices the graphics temporarily to that middle point, okay? And then I really just need to draw that line across here and dimension it from the top to that line of 11 millimeters. The thing though is that I don't have any geometry in here. I need to be able to draw the line from an actual object snap, but there's really nothing there. So right now that I hovered over it, it showed up. But another thing I can do is I can project some geometry. I can project geometry by selecting individual edges, or I can project all my cut edges. And what that does, it brings up temporary lines all the way along the edge that I can then use to draw my line from that temporary geometry across. Okay. I'm going to hit escape and I'm going to predict that it's going to say one dimension needed. I'm going to hit escape. And there it is. One dimension needed. A dimension from the top to the bottom here of 11 millimeters. It's fully constrained. Finish sketch. My sketch is in the middle, so I'm going to go ahead and extrude. And I'm going to go ahead and pick that profile right in there as a cut extrusion, symmetrical, a total of, according to my drawing, what is this total right in here? Oh no, I don't know what it is. What I do know is that it's 11 millimeters, and the total is 58. Okay, don't forget, Inventor does math for you. So I can go, my distance is going to be 58 minus 11 minus 11. Hit okay. That takes care of that part there. Okay. And then last but not least, I do need a sketch of this middle part here to draw in these slots, and they are called slots, S-L-O-T-S. So I'm going to draw another sketch here in the middle. And in there, I'm going to draw, let's see. We used to have a slot option. Oh, there we go. So under rectangle, of course, you can draw lines and you can draw circles and all that stuff. But under rectangle, you'll find this thing that says a slot. And this one is center to center, where I draw the center line and constrain it. An overall center point. So and we even have a 3-point arc slot. So we have them all different kinds of them, and we even have polygons. So based on the information that I have, I think I'm going to go with a center to center slot. This is what I think I'm going to do. Ooh, and then I'm going to do even something nicer. Very good. So I'm going to click this one, and I'm going to draw a slot from center here to center here, and like that. And then I'm going to hit escape, and I need 4 dimensions. So I can tell you the dimensions I'm going to need. If I can move this thing around, that's not a good thing. So what I'm going to do is I'm going to horizontally constrain it, constrain the point here to the origin or the center. So 3 dimensions. The other dimension I'm going to need is the radius of this guy here of 4. And then 2 dimensions need. The dimension I need is from this edge here at the bottom. So I need a dimension from this edge to this point, because that's what we have here. From the bottom edge to the center of the slot is 14 millimeters. So I'm going to dimension from this edge down here to the point right in here of 14 millimeters. There you go. You can kind of see that I actually projected that geometry automatically, which is projected from this bottom edge to this plane. And then 1 dimension needed, which is what I suspected, of the length of the slot from here to here. And that one is 19. Fully constrained, finished sketch. And then I'm going to go and extrude that sketch as a cut extrusion. The distance is going to be not a distance, but through all. So it's basically just going to go through the whole thing. Pretty much how it says on the drawing. Okay. One last thing to show you guys. This other slot over here. Okay. So this slot over here, okay, this doesn't make sense. 2 times 13, a radius of 4. That kind of doesn't make sense to me. I'll have to study that a little bit. But if anything, the other thing I was going to show you, it's as far as this slot, I hope you agree with me that the distance from the edge to the center is actually the same as this one from here to here. If we did the math, more than likely this would be the 11 millimeters that we have over here. So because of that, I can actually use a mirror command. So that's another neat trick to use. And what I'm going to do is I'm going to go over here to mirror, and going down the list, what am I going to mirror? I can go and pick my feature here, or I can go pick the extrusion from over here. That's the feature I want to mirror. And then my mirror plane. So I click on mirror plane, and then on mirror plane, I can go and pick one of these, which is why you want to use that center point, because that way I can use the XZ plane in this case. Oops, I'm sorry. Sorry. I messed that one up. The YZ plane, sorry. The YZ plane, to mirror this feature along the YZ plane from one to the other, hit OK, and you got it all at the same time. Okay. So I'm hoping this helps you on how to draw the tailstock clamp a little bit easier.